In this video, we will talk about the definition of processes and principles as well as the C programming, the examples. Okay, as you can see on the screen, what is process? A process is an instance of a running program, one of the most profound ideas in computer science. Process is not the same as program or processor. As I mentioned that many times from the first week, all right? Process provides each program with two key abstractions. First, logical control flow. What is the logical control flow? If we consider logical control flow, each program seems to have exclusive use of the CPU, and it is provided by the kernel mechanism called context switching. In chapter 1, I shows the context switching example in a specific figure, right? So it is provided by the kernel mechanism. So a kernel is the main part of the operating system, as I mentioned in a previous video. So with the help of the kernel mechanism, each program seems to have exclusive use of hardware CPU. So logical control flow is related with CPU, one of hardware, all right? The second abstraction is private address space. So private address space is related with the main memory, another hardware, right? So each program seems to have exclusive use of main memory. So it is related with private address space. It is also provided by kernel mechanism called the virtual memory. So logical control flow is related with CPU, and it is provided by kernel mechanism called the context switching. Okay? However, private address space is related with main memory. It is also provided by kernel mechanism called virtual memory. So the relevant or related terminologies are different regardless of their hardware, such as CPU, main memory. So please pause my video now and please write down these all English sentences in your written note, okay? And please memorize two abstractions such as logical control flow and private address space for process concept, okay? And please draw this figure in your written note. As I mentioned, the most questions of students in a previous video, most students ask me, Professor, can I use the iPad or other PDF file for writing my review and the traces of my lecture? It is okay, but if you draw the all relevant figures of computer structure and systems such as memory, CPU, and hardwares in your written note with your pencil, it is more efficient for memorize all by yourself, all right? But it is up to you. You can use your other devices for put your old traces with the writing or drawing the figures, okay? It is up to you. It's okay. So this figure shows the illusion example of multiprocessing. So computer learns many processes such as web browser, email client, editor, KakaoTalk, music, and so on simultaneously, right? So these are applications for one or more users, or just one user can simultaneously used in many kinds of applications, right? So in this case, as I talked the concept in chapter 1 for a long time, hardware's sophisticatedly scheduled the proper epoch or slot for each application. Okay, so each application that is process can have illusion about its the fully occupied hardware. All right. So when you look at the figure in the screen, each application have illusion for using the hardware such as the memory and CPU all by itself only. All right. For example, if we test the running program on Mac or Windows, we can check the how many processes are ongoing and how many processes are active or inactive, like that. So this figure shows the Mac example. So processes, the 123 total, 5 running, 5 stock, 109 sleeping, 611 threads, like that. So system has 123 processes, 5 of which are active. And each process can be identified with the PID, process ID number. So we will learn PID concept and the process generation methodology in C programming language on top of Linux soon, so don't worry about it. So this figure shows traditional reality. So please compare this and the next page, the modern reality. Okay, so different from the modern reality, the traditional reality has only the single processor. So single processor executes multiple processes concurrently. So process executions interweaved with the multitasking concept, and address space is managed by virtual memory system. So we will touch them in detail later, so don't worry about it. And register values for non-executing processes save in memory. So if you consider this slideshow with my lecture notes, first, the processor selects the one of the processes sophisticatedly and save concurrent registers in memory, and schedule the next process for execution, load saved registers and switch address space. That is context switching concept. So we can cover this concept in chapter 6 in detail too, so don't worry about it. As I mentioned in a previous video, after finishing chapter 1, we just started chapter 8. Chapter 8 is related with processes and exceptions, all right? So it is the middle procedure between the software and hardware. One of the hardware, maybe the CPU and memory concept, and we mostly focus on the process generation and kernel concept for the software, but slightly or cooperatedly we simultaneously talked about the hardware concepts such as CPU and memory, because it is deeply related with the concept for the operation between software and hardware. So if you are not efficient for the explanation for the memory or other hardware concept, please endure until chapter 7 or 6 or other chapters. Alright, so please follow my steps for covering whole figures with the efficient helping of your understanding. Okay? Okay. However, in a modern reality, the number of the processors were increased from single one to the multi-core processors. So multiple CPUs on single chip share main memory and some of the caches, and each can execute a separate process. So simultaneously, each processor fully occupied each separate process, and it can schedule of processors on the core than by the corner. So please think about just one single corner server in 성균관 University, for example. Corner server has multi-core processors. So that means these days the desktop, laptop, and servers have several brains, several CPUs, right? So each CPU can cover its own process very efficiently. Of course, a single processor can make thread or multitasking concept for the concurrently execution of the each process, right? But we can make the more efficient execution quickly, and we can finish our missions with the multi-core processors in modern reality, of course, right? So you can catch the main point from the traditional to the modern reality with the number of the processors. All right. Okay. So we will finish the multi-core processors concept. We will focus on the concurrent processes regardless of the number of processor numbers. Okay, so each process is a logical control flow. Two processes run concurrently are concurrent if their flows overlap in time. Otherwise, they are sequential. So please memorize the color terminologies in each slide, because these terminologies are very novel and very important for the beginner. All right, so what is difference between concurrently and sequential? So when you look at the below figure, according to the time, three processes can be executed sophisticatedly in a single processor in CPU. So CPU sophisticatedly schedule each process according to their time policy and the quality of experience of each user, right? So process A starts, but in the next time slot, process B joins and process C joins. But before finishing process C, process A finish first. So the process A and C are concurrently executed. However, process B and C are perfectly independent. So after finishing process B, process C just started, all right? So in this case, process B and C are sequential, all right? So please take further this slide with your cell phone, and please remind the deep meaning of concurrently execution and sequential execution with this example figure. All right, And please pause my video and write down and draw figure this slide in your notes and take photo and paste in your Word portfolio file with the studying date. Okay, so whenever I mentioned the main part of my lecture in this video, you can refer that comment in your notes as your as portfolio file with your cell phone. However, if you want to study or exercise or write down another the parts, comfortably write down many times in your notes, and then you can paste your old traces in your Word portfolio file. Okay, there's no template about Word portfolio file, so please show your diligent behavior and your eagerness to me for your final score. Okay. So as I mentioned, AB and AC are concurrent relationship. However, B and C are sequential relationship. Okay. So user view of concurrent processes. Control flows for concurrent processes are physically disjoint in time. All right. For example, process A and B, even though they are concurrent relationship, but the physical time slot, physical time epoch is divided or separated each other, right? So control flows for concurrent processes are physically disjoint in time. However, we can think of concurrent processes as running in parallel with each other. All right? So that is the practice program. It is very easy. So please think of this example all by yourself, and please put your traces in your written note all by yourself. All right. So consider 3 processes with the following starting and ending time. So you can draw similar this figure in your notes based on this time schedule, and then you can put your answer in the blank. All right. For each pair of processes, indicate whether they run concurrently Y or not N. All right. So if process pair A, B are concurrently, you can put Y answer here. If it is not, you can put the N in the blank. All right. So please solve this problem all by yourself, and you can write down in your notes and paste your folder in your Word portfolio file, and you can submit whenever I request your portfolio Word file in iCampus. You can upload it. Okay. So what is context switching? Already we are familiar with this figure in chapter 1, right? Did you remember it? So process A can be putty program and process B can be shell in this example. So if we try to connect putty program, we can put our ID and password, right? At this time, the operating system, specifically kernel, make the allowed to use of the shell to the process A. So process B, such as a shell, was generated, and it cooperated with the kernel part. So shell wait for the command of a user, right? So the context switch occurred about 2 times, and then after execute the user command, shell waits the another command. and return to the process A, right? Or process A can be shell and process B can be hello.c. So each process can be executed concurrently and share some necessary part, such as the corner code sometimes, and the remaining part can be separated according to their own polish. Okay, so context switching processes are managed by the shared chunk of the memory resident OS code called the kernel. So we learned about the exact definition of the kernel. The kernel was the core part of the operating system, and we already checked the location of the kernel parts on the top of the main memory, right? So kernel is shared the chunk of the memory resident OS code. The memory resident OS code. Okay, so all processes are managed by their kernel. Okay, so the kernel is the manager of the processes. Kernel is not a separate process, but rather runs as part of some existing process. Okay, so kernel code can be shared with other processes. So the kernel is not a separate process. Okay, so kernel is also one of the softwares, right? Kernel is also one of the programs, right? So if we turn on our desktop or laptop, at the time, operating system was loaded on the top of the main memory, specifically kernel, right? So kernel is also one of the processes, right? But kernel is not a separate process, but rather runs as part of some existing, the shared part of some existing processes. All right. So control flow passes from one process to another by a context switch. So we will cover these concepts too soon. So please refer this part with this explanation at this time. Okay. From this slide, we will exercise C programming with PuTTY program on top of the Linux shell. All right. Before that, there are some homework with the VI editing commands. So please repeat these uses all by yourself with enough time within this week, because whenever we try to program some examples with C programming, naturally we should use the VI editing command, right? So whenever you try to use the VI editing command more and more, you can save your programming time and you can improve your efficiency for the complementing your programming code. All right. For example, we already touched several the main VI editing command, such as I and the lowercase a and capital A. All right. However, please refer another remaining command all by yourself. So with I, we can go into the insert mode, and if we use the A in VI mode, we can write after cursor. For example, please open your PuTTY program here and connect with the port number of the establishment of 성균관 University, and you can connect your ID and password. All right, and if you want to test many kinds of VI editing command with your own basic C file, such as the hello2.c, in this case, there is a cursor here, right? But if you want add another instruction at the end of the line or at the end of the cursor, you can use the specific or special alphabet. All right. For example, we can go to the we can go to here, and if you want to write after cursor, you can put the lowercase a. All right, so you can write after cursor, right? However, if you want to write at the end of the line, you can use the capital A. For example, after ESC, you can go to the next line, and please try to use the capital A. All right? So, after enter and tap keyboard, we can add another comment. All right? My point, the lowercase a and capital A have two functions: writing and insert, right? So we don't need to put I whenever we want to write another additional instruction after moving the cursor. All right. So if you use the lowercase a, we can write after cursor without I. Capital A, with the capital A, we can write our instruction at the end of the line without I typing, all right? So, you should do your homework with the hello.c program. You can use the all cases of VI editing command of this screen. So please open your portfolio Word file, for example, and please put your current date, your studying date, on top of or at the end of your the contents of your own portfolio file. For example, you can put or your date, all right? So your studying date, and then you can paste the VI editing command example figure here. All right, and first case is the I. So you can put each command's definition in English or by yourself too. Insert at cursor. So goes into insert mode. So here you can put your own example. So for example, with the hello.c, I go to the command modes without save, and I can go to the hello2.c file again with the exclamation with V. Alright, and then please check your cursor location first. Alright, and if you want to put another printf function here, you can use the first, if you want to use the lowercase a example, we can go to the cursor here, and then we can put not capital, lowercase a, and write immediately without I typing, right? So for example, additional example, all right? And save with this comment. So WQ exclamation and enter, right? And we can compile with the GCC, the object, and the hello to the execution file name and original file name here, right? I have a typo here, right? So in this case, you can use the modify the last comment with the side key, and then I can put the hello to the C here. All right. So if you want to execute the latest execution file, I can put the concurrent, the special keyword, and the execution file name is hello 2, right? So that is the proof of the first comment, the lowercase a. So it will take a long time if you do all cases test from the I mode to the last, the VI editing command, right? So in this case, I copy with the Alt print screen simultaneously with the keyboard, and then paste here. And I can also VI mode and copy and paste with Alt print screen in keyboard, and first I paste the source code, that is the source code first, and then execution cases. All right, so you can test each VI editing comment in your own shell and paste the source code and result. Okay, so for example, I shows the I case only. All right, so similarly, you can put your all traces from the I to the last VI editing comment. All right, so shortly I will leave you the each VI editing comment. As I mentioned, capital A can be used for writing at the end of the line. Okay, and ESC, terminate inserting mode. Alright? And lowercase u is undo, last change. The capital U, undo all changes to the entire line. So please memorize most VI editing command for your efficient programming. Alright? And lowercase o, open a new line. Alright? For example, please test with your own hello.c with the last example. If you put the lowercase o, the cursor move to the next line, right? And we can't write right now. So for the indentation, I push the tab here first, and then we can add the another printf here, for example, alright? So the lowercase o go to the next line. How about the capital O? Even though I missed the capital O case here, but creatively, comfortably, you can imagine the opposite case, the capital O, even though I missed some cases, alright? So we can imagine, oh, if we use the capital O, maybe cursor can be go to the top line, the next top line, not bottom line, right? And then we can add the another instruction. For example, if you type the capital O here, as we mentioned, the cursor move to the up line, and then after indentation, we can also add the another printf function here. So it is very important concept. Okay. So I recommend you use this, the VI editing command, as well as these cases, right? And these are very, very basic concept. ESC and I, right? Go to the insert mode, terminating insert mode, right? Okay, and this is also very, very basic command, dd. So if you want to delete this line, you can type dd. So we can't delete the current line, right? But if you want to 2 or 3 lines simultaneously, we can use the number in front part of the dd. And if you use the only capital D, we can delete contents of the line after the cursor. Okay? And how about capital C? We can delete contents of a line after the cursor and insert new text. So please differentiate these cases all by yourself with enough time, and you can paste all your testing cases in your own portfolio file. Alright? And how about DW? Delete words. For DW, delete 4 words. CW, change word. X, delete character, single character at the cursor, at the current location of the cursor exactly. Alright? And we can replace character with R, and we can overwrite characters from cursor or word with the capital R, and we can substitute one character under the cursors, continue to insert with lowercase s, and we can also have the the opposite effect with the capital S. And we can change case of individual character with this, the special character. All right. Okay, that is the first page of the VID editing comment. Next page is the more complicated VI editing comment. So there are some overlap cases also, but this slide shows additional more complicated VI comment. So you can you can think the unoverlapped cases, first page and this page all by yourself, and compare and then test all cases all by yourself and paste in your word portfolio file of your old traces. Okay, and for that you should use the notes and explanation for that. All right, so in this video, we talk about the exact definition of processes and the context switching as well as the VI reading comment. So I will upload these slides previous in advance for before the next video. So based on the VI editing comment with the process definition, please preview the C programming code all by yourself first, and then please complement your own C codes equally in your server, the folder after login with your ID, and then test and modify all errors, and then please submit your C codes in your portfolio Word file too, and I will explain each meaning of the instruction deeply in the next video. All right, so please preview this C programming code with VI editing comment with enough time, because it will take a long time and it is very important and helpful for you. All right, so please take photo this slides and type in your server folder, and then test all cases, and then please take a look the proper and the sophisticated the explanation in the next video in the next week. All right, thank you so much. See you next week. Bye bye.